Welcome to the Explainer. So, today we're taking something that, let's be honest, a lot of people view as just a tedious chore, and we're completely reframing it. We're going to look at mathematics not as a series of boring, repetitive exercises, but as the vibrant, pulsing source code of the entire universe. If you've ever felt intimidated by long strings of numbers or kind of wondered why we even bother studying stuff like abstract algebra, today is absolutely going to change your perspective. We're diving into the power of encoding our reality, pulling some incredibly fascinating concepts straight from the book Majesty and Monotony. So buckle up, because we are about to see the everyday world from a truly cosmic perspective. To kick things off, we really need to flip the script on how we view repetition. We tend to think of monotony as dull, right? Like it's lacking life. But look at this incredible quote from the philosopher G.K. Chesterton. He points out that children want a joke or a game repeated over and over again, not because they're bored, but because they have abundant energy. They are fierce and free in spirit. In fact, if we look at minimalist art, think of the works of Donald Judd or Pete Mondrian. We see artists using repetition deliberately. It's this fierce, willful, and highly meditative energy. It literally structures reality. So if we apply this mindset to the universe, mathematical repetition isn't boring at all. It's a very deliberate, dynamic force. Okay, let's dive into this, because this question fundamentally changes everything. If nature constantly repeats itself, in the cycles of the moon, the orbit of planets, the spiral of a seashell, then what we normally call the monotony of math is actually just the universe speaking to us. It's the most universal tongue there is, one that tells the story of how absolutely everything around us is structured. Today, we're going to explore exactly how humanity learned to translate this cosmic language, and how doing so quite literally rewires our brains. All right, part 1, the code. Visualizing cold, hard logic. So, to understand how abstract mathematical logic maps directly onto the physical reality we experience every single day, we kind of have to bridge a mental gap. The author of Majesty and Monotony calls math the language of cold, hard logic. Now, when you see a chalkboard filled with complex functions, it looks incredibly intimidating, doesn't it? It feels like this impenetrable wall of genius that you just can't get past. But Majesty and Monotony gives us this brilliant reframing. Every single mathematical symbol is really just an abbreviation for a word or an idea. That is literally all it is. And when you string those symbols together into an equation, you aren't looking at some mystical, unbreakable code. You're simply reading an essay written in logic. Once you realize equations are just logical stories being told step by step, the intimidation factor completely fades away. Let's actually look at how one of these logical essays is written out. Early scientists started with really basic observations. They logically deduced that the physical force between two objects, let's say two planets, had to be proportional to how massive they were. That's your big M times the little m. But they also realized that the further apart those objects got, the weaker the force became, and that gives us the r squared at the bottom for distance. See? They are quite literally writing a story about how mass and distance interact out there in the real world. Now, what's really interesting about this is what happens when you actually test that story. When scientists measured actual weights and forces, their theoretical guess was, well, slightly off. But they noticed the ratio of the difference was exactly the same every single time. So what did they do? They simply slapped a constant into the equation, capital G for the gravitational constant. And by adding that one simple letter, the essay is perfected. This equation now works universally, whether you're calculating a falling apple right here on Earth or the massive collision of distant galaxies. Of course, as these logical essays get more and more complex, our brains need a little help. This is where something called dual coding theory comes in. Educational programs leverage visual schemas to anchor incredibly dense math. By providing a visual flowchart for abstract algebra, or a 3D graph for multivariable calculus, we effectively distribute the cognitive load. Usually, these subjects are taught with dry, imageless strings of symbols, which is tough. But by utilizing our brain's visual spatial sketchpad alongside our verbal processing loop, we drastically improve our mental encoding. We are literally visualizing the logic. Moving on to part 2, the constant. The universal ubiquity of pi. Stepping away from the cold equations of gravity for a second, we find that the universe absolutely loves to repeat certain words, and none are more famous than pi. At its core, pi is just a simple ratio, right? The perimeter of a circle divided by its width. Because spheres are the default shape of celestial bodies, pi is everywhere in space. But it also dictates pretty much anything that happens in a cycle. Pendulum swinging, springs bouncing, quantum waves. Even the music you listen to depends on pi because sound is a wave.
And get this is mind-blowing. If you take the actual winding length of rivers on Earth and divide it by the direct straight-line distance from start to finish, the average is incredibly close to pi. The theatrical contrast here is just astounding. A simple geometric circle secretly governs the vast cyclical phenomena of our entire reality.
And this next point brilliantly illustrates just how deep this rabbit hole really goes. 64%. In statistics, when you look at a normal distribution, the famous bell curve, it tells us how data differs from an average. Exactly one standard deviation more or less than the average will encompass about 64% of the total data. Do you know what 64% roughly equals? 2 divided by pi. No way, right? Pi isn't just in the physical curves of rivers and planets, it is woven directly into the everyday statistics of human life and data modeling. All right, part 3. The void, the evolution of zero.
Let's move through this and see how this builds, because humanity's ability to finally grasp and encode the concept of nothing completely revolutionized our ability to measure everything else. Look at this chronological evolution. Some of the earliest signs of math are tally marks on bones found in the Congo, which were used just to count basic resources. Fast forward, and empires like Rome developed standardized quantized measurements, Roman numerals. But the real absolute breakthrough happened in the East with Arabic numerals. That gave us the concept of placing a zero within and behind numbers. And that unbroken line of evolution, it leads directly to the 21st century, where our entire global digital community runs entirely on a foundation of ones and zeros. Understanding human progress really requires looking at this stark contrast. The Roman system, which was brutally maintained for centuries, it was even defended by the early Catholic Church just because it was familiar, was incredibly clunky. Actually, try calculating interest or complex trade with Roman numerals. It's a nightmare. But the Arabic zero was a real game changer. By allowing numbers to easily scale, humans suddenly gained the ability to calculate the infinitely small and the infinitely large. Zero is the exact key that unlocked the mathematics necessary to peer into the hearts of black holes and trace time all the way back to the very dawn of the universe. Which brings us to our final section, Part 4, the game, strategy, simulations, and mastery. Taking everything we've discussed so far, we can actually apply this cosmic code directly to personal strategy. Math and logic inherently teach us a powerful philosophical framework known as the dichotomy of control. This is a core Stoic principle. Think about a game of chess. It's essentially a pure mathematical matrix of variables. You have total control over your strategy and your moves, but absolutely zero control over what your opponent does. By approaching life like a math equation, isolating the variables you can control and just letting go of the ones you can't, you navigate high-stress situations, exams, and conflicts with total clarity and zero anxiety. You focus only on optimizing your side of the equation.
So the crucial point is this. Engaging with this material isn't just some dry academic exercise. It is a literal brain change protocol. When students use adaptive learning platforms, or when strategists practice advanced mathematical tactics in simulated wargames, they're doing so much more than just memorizing. By applying these rigid mathematical rules to chaotic simulations, and thanks to neuroplasticity, every single time you master a new, complex variable, you are physically forging new neural connections. You are fundamentally refining the hardware of your brain by repeatedly running the software of mathematical logic. And that leaves us with the ultimate philosophical question to end our explainer today. If math allows us to predict the exact existence of a planet before we even see it through a telescope, and if its logic so perfectly and universally simulates the reality we live in, was this cosmic code simply discovered by human beings, or was it invented by us to make sense of the chaos? It's a profound mystery that bridges science and philosophy, and it ensures that the majesty of this monotony will keep us wondering for generations to come. Thank you so much for joining me on this deep dive today, and I really hope you leave here seeing the hidden equations all around you.